Hello guys, Mr. G here. We're going to continue with another video from the question paper on 2016 June. A question paper that was done in the Free State and the Northern Cape province in that year. So we're going to be doing question 3, but before that, please don't forget to subscribe so you can get all the notifications as well as all the videos I post on regular basis, and you can get the other videos on questions 4, 5 and 6 I already answer. So we're going to do question 3. I didn't follow the same order of the question paper because I was doing topics first of all that you were doing at school at the moment, and now we're just doing different questions. It doesn't really matter which question do you do first. So we're going to do question 3, and said this one is about vertical projectile motion. Say a stationary rocket on the ground is launched vertically upward. After 4 seconds, the rocket fuel is used up when it is 225.6 meters above the ground, point R. In this instant, the velocity on the rocket is 112.8 meters per second. The rocket reaches the maximum height above the ground at point S. Ignore the effect of F friction and assume that G does not change during the entire motion of the rocket. They say that one because G, acceleration due to gravity, depend on the height or the distance, so that is why they say that. Here is the picture, guys. You can see the picture there. And now question 3.1, draw a free body diagram with label of all the forces acting on the rocket at point P. Now point P is right there. The rocket still moving up with the gases inside the rocket, so there are 2 forces acting on that rocket, okay? And they said here, ignore the effect of friction, which is a little bit difficult because the rocket is moving too fast, so there will be definitely A, but it's fine. They say ignore. So we're going to be doing question 3.1 right on this side here. 3.1 here. Now 3.1 is the free body diagram with all the forces acting on that rocket, and they say the magnitude, the length of the vector of the arrows should be an indication of the magnitude of the forces. So now, what forces are acting there? First of all, there is a force of gravity downward. Let's move the dot a little bit up. So there is a force of gravity down, which I'm going to call weight. That is the first force I'm going to draw on the rocket. But the gases is also pushing the rocket upward in this case. And that will be the force from the gases on the this is a little bit tricky, but that is the force that is pushing this rocket up. I'm going to write the force from gases on rocket. That is the force. Alright, so those are the 2 forces acting on that rocket at that specific point. Remember, when it reaches point R, then the gases are done. Then the only force acting will be weight, and therefore it becomes a projectile. Okay, so this is question 3.1. Question 3.2, what is the direction of the acceleration of the rocket at point P? Now at point P, the rocket is moving up. The net force is moving up. As you can see, the force of the gases is greater than the force of gravity or weight, and therefore the acceleration is going to be upward. So at point P, the acceleration is upward. This one is Newton's second law. The acceleration is in the direction of the net force, and you can see the force upward from the gas on the rocket is greater than the force downward of gravity. Now at point Q, the rocket is no anymore moving upward with the gases acting on it. So it's moving upward as a projectile. The only force at point P, the only force acting will be weight. Then it's a projectile, and therefore the acceleration is downward. So at that point, the acceleration is downward. At which point P or Q is the rocket in free fall, and we already spoke about that one. It's at point Q. These 2 points they asking about. At point Q. Why is at point Q? Because weight is the only force. This one is the only force acting. That is the only force acting there. So let's answer here. So the answer is Q, because gravitational force is the only force acting on the rocket. Take upward motion as positive and use only equation of motion to calculate the following. The magnitude of the acceleration of the rocket between ground and point R. Note the following. At that distance between ground and point R, this distance here, the object is not in free fall. So the acceleration is not the acceleration due to gravity. So we have to use equation of motion that you did in previous grades. Now, you have to note something important here. The rocket was stationary at first. So from that point, it means that the initial velocity of the rocket is going to be equal to 0. You do have the time it takes and you have the distance it takes. So there are many formulas that can be used at that point, but let's as usual write the data for question 3.4.1, which we are going to answer at this point. 3.4.1, and we are going to write the data we have here. Alright guys, here is the data, here is all we have. And note the following. In the question they say you have to use up as positive, so you cannot change that. Let's go to the formulas. Now, these are the formulas you have to use, the formulas or equation of motion. And now for that question, in actual fact, you can use any of the equation because you have everything in the data. So anything between those three that have acceleration, you cannot use this one because this one do not have acceleration, and that is what you are looking for. So either of them. Now for us, the easiest one is this one, is the one that have less numbers and substitution there. So when you write the formula here, is the final speed is equal to initial speed plus acceleration multiplied by the time. Remember, this acceleration is not the acceleration due to gravity. So when you substitute everything, the answer is going to be 28.2 meters per second square. That is the answer of the magnitude of the acceleration. And the question asks for the magnitude of the acceleration. So that is the answer there. Question 3.4.2, the time it takes from the moment the rocket is launched until it strikes the ground. So guys, very, very simple. All we have to do is to calculate the time it takes from point R to the ground as it moves all the way up and down. But here we're going to use only one equation of motion. In this case, if we do that, this one here is the displacement there. This one here is the displacement. So if you use the following formula for the displacement, is equal to initial velocity multiplied by the time plus half acceleration. That case is acceleration due to gravity multiplied by the time square. In this case is acceleration due to gravity. Guys, this time is the time to reach from R to point ground. That is all we are going to do. Other people may calculate time to go up, time to go down, but we are going to use only one formula there. We have the data is more or less the same data. The only difference is that now we have acceleration due to gravity because it's a free fall. The total time, then we'll have to add the 4 seconds. Okay guys, so here is the data for this part of the question. The only difference is we have acceleration due to gravity, and because they said take up as positive, is you note here the displacement, which is this one here, is downward, and therefore it must be negative, as well as the acceleration due to gravity. So if we substitute, if we write the formula that we are going to use in here, which is displacement equal to initial velocity, also changes what it was final first, now is initial multiplied by time plus half acceleration due to gravity multiplied by time squared. Now let's substitute everything we have in here. And guys, here we are in a quadratic equation that have the form ax squared plus bx plus c equal to 0. So we are going to use that one and use the square root of the weight of the calculating the quadratic equation. And we are going to use this formula. So we are going to use that formula for the time. And when you do that, you have obvious two answers. You have one answer in which time is equal. If you substitute the positive, you'll get minus 1,85, which is not right because you cannot have a negative time. And if you substitute the minus, then the answer for time is going to be 24,87 seconds. But now this one is not the total time. This one is the time, as I told you before, is the time from R to the ground. But from the ground to R, it was 4 seconds. So the total time that this rocket was in the air, the total time, T total, is going to be equal to the 4 seconds plus the 24,87 seconds. So the total time is going to be equal to 28,87 seconds. This one is the total time and the end of that specific question. Now to finish this question 3, all we have to do is to do question 3.5, which is about graphs. And so this question says, take upward as positive and sketch a velocity timed graph for the motion of the rocket from the moment it was launched until it strikes the ground. Indicate the following values on your graph, and they give you a list of values you have to indicate it there. Okay, so what is going to happen here? Okay, you need to know that the rocket starts moving all the way up from 0 meters per second up to a point which is at 4 seconds. 4 seconds. Here is a point of 4 seconds in which the velocity at that point is 112,8 meters per second. Now at that point, the rocket's still moving up, but it does move, still moving up, but the velocity decreases now up until stop in certain points. So now it's moving all the way down, or let's say move all the way up. The graph is pointing down up until it reaches the maximum height. This point here is at the maximum height. That is at maximum height, which don't have that time because we did not calculate. Now what happened there? It changed direction. It changed direction and started moving all the way down. The velocity is going to increase. No, this one is a straight line. It must be a straight line up until sometime reaches the ground. This one is a straight line. Let's fix this side here, which is I don't know why it did that one. So here now we go all the way up. At that point, that whole motion, it took, up until that point, it took 28,87 seconds. And guys, we don't know the velocity. It was not asked in the question. They didn't ask to mention here. This is what they want us to know and what they want us to represent in the graph. So this is the graph. I hope you understand. This is the final question of this, the final part of this question and the final question of the video. I hope it helped. If it helps, subscribe for the channel. You can ask questions, you can comment. Thank you for watching. I'll see you next time. Mr. G here.